Thank you so much for joining me today. As I was thinking through my slides and my themes, I always have my children help out and have a little say. So my daughter, Emma, asked me, well, what are you talking about? And I said, transformation. And we had just done a whole science museum exhibit, and she was, oh, like the monarch butterfly. So there you have it. If you need any random monarch tidbits, I can certainly ask her, because she knows everything there is to know about every animal and bug on the planet. So it's been an interesting journey for me. As you said, I'm an architect at Blackboard. And I started at a time when we were all manual, all waterfall. And it's been amazing to see us transform over the years as we go towards continuous delivery, trying to become a high-performing DevOps organization. So I'm also on the steering committee for the Selenium project. So just a side note and shameless plug, please submit. We have an open call for papers right now for the Selenium conference in India, and we close March 12th, and we'd love to see your ideas. We also cover speaker travel and accommodation, so we really hope to have you there. And I've never really talked about my internships before in the past, but these were actually my first exposure to testing and monitoring in a very roundabout way. So I interned at the Department of Transportation for the National Highway Traffic Safety Administration, or NHTSA, in their Research and Development Department. There I assisted with driver distraction research and event data recorder collection. And so of course, as I developed this talk, I thought, oh, nobody's going to ever know what NHTSA is or talk about it. And sure enough, Gil Terr just shows NHTSA right up there on his talk on autonomous vehicles. But there you go. It was awesome to see that. And I spent some time with the Center for Applied Biomechanics at the University of Virginia. And I started as an IT intern there. But because I was the only person with my hepatitis B vaccine, I became a circulator during car crash testing with cadavers. So that was my first job in testing. One question that still stands out over the last 20 plus years is, what do you think is going to happen to this tibia and fibula when we do this crash test while they're holding up the cadaver's leg? That's, I don't know, 20 years, it's just still stuck with me, and I still sometimes have crazy random dreams about, severed body parts circling my head. It's crazy. But regardless of my career trajectory over the years, I can without a doubt say that this has been my personal experience with change. Whether a new job or role, a new boss, a new life event, a new direction we need to take but no idea how to start, it can all feel so overwhelming. Exciting, of course, but every time for me, overwhelming. Another truth I found in my life is that the change we seek is not usually sudden. Some change can take years to see the effect. But how can we lay the groundwork in the roadmap and manage expectations for that change? So I want to talk about how we can use DevOps principles of collaborative practices, iterative improvements, and incremental testing. We'll cover some of my experience that I hope you may all relate to in some way. And I hope you walk away learning some practical things you can take back with you to your teams, and also leave thinking about what the future holds for you and your teams. I'll also be covering something a bit different, and perhaps the last place I'd look for DevOps practices, the United States government. We'll talk about how crash testing and vehicle safety has evolved over the years, how the government collaborated beyond the walls of their office and took down silos, how they look to continuous or iterative improvements in vehicle safety and incrementally improve their testing programs. This is a special talk for me as I dedicate this to my dad. His life's work is represented here. He worked for NHTSA for 32 years in the Office of Applied Vehicle Safety Research. He was responsible for projects relating to vehicle structures and occupant restraint systems, human injury biomechanics, crash avoidance, and heavy truck safety. So if you like your seatbelts and your airbags, you have him to thank for that, as he's the one that helped standardize those and get the legislation in place to make them standard in your cars. And when I turned 15, I think he brought home every crash test video ever known to man for all of us to watch. So I certainly buckle up, and I have never once been on a motorcycle and never will be. And even in retirement, he still dedicates his time to vehicle research and safety. So here, as you can see, he's talking with Elizabeth Warren as part of the American Chemistry Council, working towards more fuel-efficient vehicles and higher safety standards through his time off. So let's get started and take a look at the confluence of events, both in the automotive industry and in our world we were facing that triggered the impetus for change. I'll start with automotive safety. This is an image of a frontal car crash conducted in 2015 with NHTSA. But we didn't always have this. Consider when automobiles hit the market. The Model T came out in 1908. There was no testing. Testing didn't start until 70 years later. We also have over a 40-year period before seatbelts are offered at all in American cars. Manufacturers could go to market without truly ensuring safety for their customers. Fatalities were on the rise. We have more and more affordable cars, therefore more drivers on the highways. Cars got bigger and faster. We weren't going 12 to 15 miles per hour anymore like the Model T. Something needed to change. So in our world, let's look at some factors that I've seen throughout my career, and perhaps you may notice some patterns too. I've seen a variety of attempts at automation. Some teams that created an automation framework, but other priorities took hold, had been disbanded. Developers sometimes wrote tests, but quickly forgot about them. Other automation teams were writing the tests and also maintaining all of the tests. And in both cases, a lot was written, but became very difficult to monitor and to maintain. The tests existed, but that was about it. Results were all over the place. I think is everybody familiar with these dashboards? So this is an example of our overall release, job running everything to get an idea of how our 400 tests at the time were doing. You can see where we had as many failed and skipped as we did passing sometimes. And sometimes they passed and sometimes they didn't, but it was never the same test twice. They weren't reliable. The constantly failing builds were a quick way for developers to stop caring. The notifications had become white noise. I know I get annoyed when I see just red throughout all of Slack for no reason. So the teams were still in a world where primarily developers developed a feature, testers defined tests and executed them, or automation engineers wrote the tests and maintained them. And in most cases, it was a team of 5 or so at best supporting over 100 developers. That just wasn't sustainable for us. We needed to change the fabric of our teams as we know it. Something needed to change. In both cases of our national highway safety, and some teams I've worked with, we needed to consider how effective we were being by changing nothing. For car safety, how could the nation come together and collaborate to stop the increasing fatalities they were seeing? For our teams, perhaps yours too, how could we move forward so we didn't repeat the past? So one of the key practices that I feel DevOps embraces is how we collaborate. How are we organized? How do we work together? We need to set ourselves and our teams up for success. So in 1966, Congress passed the Highway Safety Act and the National Traffic and Motor Vehicle Safety Act. This authorized the federal government to set and regulate motor vehicle and highway safety standards. The Department of Transportation is formed. This became the home of the Federal Aviation Administration, the Federal Highway Administration, and among others, the National Traffic Highway Safety Administration, or NHTSA. This group needed a specific focus, and their mission was to reduce deaths, injuries, and losses resulting from crashes. And note, the important takeaway here is that this was meant to be a very forward and future-thinking mission, always something to continuously drive towards. Now, there are a lot of good testing books out there, but when you are really looking to make a major change, this has been a good guide for us. Many of our changes stem from this, adapted to fit our team's needs. And first, we took a look at what our department wanted to be. Is our job just a test? I'll give you a minute to read it. We are here to enable development teams to own testing and own quality. So we created our engineering productivity department. There are several ways to do this. You may not call it EP. Your testers may report into engineering managers directly. You may call it QA. But if you find yourself in a world where developers are not owning quality, this could be a good start for you. We intentionally did not call ourselves QA because we wanted to separate out the idea of QA as a role versus whole team quality. We were not just testers. In this case, we had our testers, our framework team, and the CI/CD team. And with our department rebranded, we needed to think about our mission. How could it be future thinking? How could we continuously build towards it? I don't remember any time in my career where I've had a mission statement beyond the corporate level, and I'm really glad that we did this. It's driven our goals and priorities. It's helped me as a PO to make decisions to ensure we are fulfilling this mission. So we wanted to reduce the time from concept to deliverable, our lead time, and provide teams with the tools, practices, and support to increase their productivity, their throughput with quality. So I was really excited when we saw Nicole yesterday give her keynote. Has anybody here not heard of the State of DevOps report? No, good, okay. So with this in place, it was time to set up our goals. First, we wanted to ensure our framework enabled Scrum teams to add and remove tests easily. Note I did not just say for testers to add and remove tests easily, but for the Scrum teams. Then, we wanted to enable the automatic and early detection of failures. While we were running some of our tests on every merge, we still had a bunch that were run only once a sprint, maybe once a night. So how are we detecting failures earlier? And how are we enabling faster feedback to Scrum teams? So once we could detect the failures, our next goal was to prevent those failures from going any further downstream in our pipeline. To meet our mission and goals, we needed to build our teams and set them up for success. Sorry. Here are just some of the amazing people I've had the privilege of working with within our EP team. This was on my last trip to DC. In our department, the testers were embedded in their feature teams, and they help facilitate what needs to be tested. I'm going to focus on our automation framework team for a bit here. So we started with the technical PO, and it's me. The technical PO understands the technical needs and works with others to prioritize against the needs of the business. This job, essentially for me, turned into sales, albeit internally. I had to sell ideas, sell against features and competing feature work that needed to happen for us to tackle all of our mission as well. I've had to say, hey, we should stop all feature work so we can get through the right tests in, and that's really not a fun conversation to have. Next, we had our Scrum Master, and this person is our Task Master. She keeps us honest and ensures that we don't bring in any story unless we all agree on acceptance criteria, and make sure that we adhere to a definition of done. Then we have our SETs, or the Software Engineers and Tests. These are truly engineers that focus on testing frameworks, establishing the best practices to roll out to the Scrum teams, but not writing the tests themselves. They enabled Scrum teams to add or remove tests into the frameworks that we rolled out. And there's more. This is just the DC people. And then we had our engineer, our unicorn, somehow we found a developer from our feature team that was super passionate about our tests and fixing tests and agreed to join our team. She's been critical in our relationship with developers as we introduce change and cultural shifts. This was also critical from a past experience where, as you saw with our results, developers weren't trusting us anymore. So getting this visible buy-in from one of their own was incredibly helpful to us. And another of the key pieces to our success is the continuous integration and delivery team member. So meet Fred, he's our stick figure here. He's off in Australia. Unfortunately, I don't have a picture of him. So he was about 50% allocated to the team. And we did this for a couple of reasons. We already, instead of bringing in a new person or having that existing role with the SETs, even though they had the skill set to roll out the CI/CD pieces, we already had that team in place. But we just found that the best way for us to initiate change is to have those that have the current trust and respect of the other engineers to help contribute to our mission and goals. And so now we have somebody that knows the business needs and could prioritize. We have somebody that can protect the team. And then we have the key people in place that could help tear down the silos and get things done. They all understand the stories, acceptance criteria, and definition of done. And even though they may not be able to implement each story individually, like in the true agile maturity model, we still could all speak the same language. We knew everything going on with every piece. So now as organizations and teams are formed, it's time to get to work. As I said in the beginning, your team may not be set up, but the end game isn't going to be complete in a night, a sprint, or a quarter. If you've done this that fast, I would love to hear how you did it and talk to you about hiring you. But let's look at how iterative improvements can help us meet our goals. Looking back, we see these iterative improvements in vehicular safety. This is a picture of Nils Bolin, my dad knows him, who was an engineer at Volvo. He gave his 3-point seatbelt design to the world for free in 1959 in the interest of public safety. He open sourced his design to be better for humanity. We also see headrests added to reduce the impact of whiplash. And we see airbag design and installation improve from driver side to driver and passenger side to the curtain airbags, And interesting, I was watching a documentary called Code: Debugging the Gender Gap the other day, and it's a fascinating movie, and all of a sudden I hear airbags. It's like, in a code movie? But it was about the team of engineers that designed the first airbag. When they invented and rolled that out, think about who was on the team. It was all male engineers. What they found in the field is that the airbags deployed way too aggressively for people of a small stature. They were only designed for the men that were on the engineering team. They had to iterate and improve that so that women, children could survive. Although they're still not designed for children, and that's why children are still supposed to be sitting in the back seat. And not only that, they improved their monitoring. That ding when you haven't buckled up is your car monitoring your behavior. The tire pressure monitoring system, or TPMS. And my new favorite is the rear seat monitoring that detects if your rear door was opened before you exit the vehicle. There's so many tragic stories of children being in a car, so all of this monitoring is helping us to change our behavior. Over time, these iterative improvements drove toward NHTSA's vision in combination with the automotive manufacturers to keep drivers safe. They collaborated with scientists, car makers, and Congress. They helped iteratively improve car safety through research and experiments, working with Congress to produce legislation that would help ensure driver safety. And in talking with my dad, NHTSA has always called this continuous improvement before DevOps was even a thing. So how do we know what to begin to improve and iterate on? Do you know how value gets to the client from concept until it is in their hands? Some people do a value stream map. And if you look at this, it's where you look at all the work going on from concept to deliverable, including the time it takes to do each bit of work. This will help us understand our lead time And let me tell you how excited I was again. Like I said earlier, just seeing Nicole just was awesome. But the larger the changes and the longer your lead time, the more heroics you're going to see. And that's where, I think we've all felt the burnout. We've all had to make heroic efforts to get a release out the door. We want to reduce that. So take a look at what takes the longest. Look into ways to reduce that time or eliminate waste. So this is where a skilled PO, especially a technical PO, can come in and help weigh that against other challenges with the business. So value stream mapping can be very extensive and requires a lot of collaboration among all groups to get started. It's still incredibly valuable, but sometimes you don't have that luxury of time just to get going. So I was introduced to the concept of a straw man last year, and we wanted a high-level vision. In our case, how does our code get to release, and what feedback do we want along the way? And we knew it wouldn't be an end state, but as we tackled each piece, we knew it was going to change, and it would encourage and guide iterative improvements, and it would help facilitate conversation. So here's an example of a straw man I created. You're not meant to be able to read it. But I know this is going to change, and our goal in this example was to have a vision to what we wanted to build towards, from code commit at the top through to release. We can conceptualize how we want our code to flow through the pipeline, as well as the feedback we want and when we want it. And how that code in the test, at least here at a high level, goes through to release. This wasn't the final word, as I said, but it helps us see what we wanted to build towards. And I found just lately, most of the people on our team are just such visual learners. It's just helped us build towards that. So now we need to identify the work based on our value stream mappings or our pipelines, whatever we want to do. Maybe as you did your VSM, you've seen an opportunity to increase speed by parallelizing your tests. That's a story. Add it to your backlog. Maybe as you designed your straw man, you see where you want to introduce a gate. That's another story. Add it to your backlog. Are the tests trusted? If not, what work needs to be done to stabilize them? That's another story, or in our case, an epic of a ton of stories. But that's how you start slicing it down. So do the smallest thing possible that helps achieve that value. Get small, quick successes with your team. Show iterative improvements over time and how you're building towards your mission and goals. And as we understand the work, we need to prioritize. This will help groom your backlog. Here's where your PO comes in to help balance against the needs of the business. Maybe we need to pause on implementing our cross-browser testing, sorry, Sauce Labs, if the company needs a microservice testing strategy in place, because that's how they're going to be delivering very soon. In the end, car safety, software development, while it doesn't move at the same pace, I swear it goes in dog years in the government, they're all doing iterative improvements to provide value over time. It doesn't happen overnight. So in the straw man, you may have noticed something. We had a bunch of little diamonds in there, and each of those represents a test suite. Not a huge, massive regression suite, but incremental testing to get us through to release. So let's take a look how this incremental testing can also help us on our journey to fulfill our mission. As NHTSA gets its research going in 1970, we start to see testing take shape. In 78, the first frontal impact test occurs. But they didn't say, okay, we're done. They keep investigating, they keep experimenting, they keep monitoring to show where to focus next. The 5-star ratings were introduced in 1993, where car manufacturers had to publish this so consumers were aware of what was going on. In 96, we see side impact testing. And then in 2001, we introduced rollover testing as our techniques improve. And this is because SUVs started and continue to be over 50% of the market share, and their propensity to roll over was so high. As NHTSA is monitoring what's going on in the field, they knew they had to add this testing in. Fatalities were at an all-time low since NHTSA was formed. That black line is the year NHTSA was created. And in 2011, we've seen it, until that point, we've seen it plummet because of all of the incremental testing over time being added. And this was for a variety of factors, other than the iterative improvements in monitoring and the legislation in place, but these socioeconomic reasons, like the recession, gas prices were escalating, fewer people were on the highways because they couldn't afford to drive. So not just what are the tooling we have in place, but consider your environments and the other external factors that may be impacting you. And beyond that, we begin to see behavior change because of all of this. In 2015, more people are buckling up than ever at 87%. So just as the automotive industry looks at incremental testing along with iterative improvement to drive towards safer vehicles and lowering fatalities and injuries, their mission, we must look at the feedback we're providing our engineers as testers. I've worked with teams that have had the massive regression test suites. We started with 45 people. That took 3 weeks to run the manual regression suite. Then automation entered our lives, and I've talked about it elsewhere along with Greg. But we strictly converted the manual test suites to automated tests without refactoring. Do not do that, ever. Or considering if they should even be automated. So we wanted to consider a different way. In incremental test suites with sub-suites, think kind of plug and play, that would tell us something different along each phase in our pipeline. So we designed our pre-merge, our build verification, and our release readiness suites. And you can see for the purple, we have 2 defined in there. So let's take a look. Here's an example of one of our pre-merge suites where we run the unit and our E2E test. We got them to run fast enough, so why not have that faster feedback as soon as possible on every pull request? On the left here is an example of our back-end build verification suite, and the front end is on the right. But again, for each suite, we're asking a business question. So why are we doing this? What value is this suite giving us? And here you can see we go a little crazy with smaller suites. We haven't even scratched the surface on building out all of these yet. But we also started taking a look at what we had in place and what we wanted to remove. So the gray box over there is the suite that we see no value in anymore. It wasn't answering a good business question for us. So to help us understand in depth what suites we want and think we will need, before we begin any work on them, or the frameworks that we may want to implement to support that feedback, we need to really think through the test suite design. This was inspired by Katrina Clokey on her book on testing in DevOps, and she has a great blog with a lean canvas. And I modified this a bit to meet our team's needs and questions I felt we weren't really answering but needed to consider based on our experiences. You should walk through this canvas as a team, not just as the tester or the automation engineer to answer this, to consider the implications of each answer that you're providing. So as you saw before, understand the why. Ask that business question for what you're trying to provide value for. What are your dependencies? What must be functional for this suite to run? What are your constraints? What's prevented you from doing this before? It may not be a technical constraint either. Ours were emotional. We had to rebuild our trust with our developers. That has completely constrained us from moving forward with more automation until we started to rebuild that relationship and prove that we could do this well. Look at when you want to run them. How long should the suite run? How will I generate the data? But the 3 at the bottom are the ones I feel are often the most neglected. What happens if there is a failure? Who is expected to respond? In the past, it was always our automation engineers. But as we start proving this out and really think through who's expected to create this and maintain this, we can't create a suite if we can't sustain it. So we really look at who should be responding and having the developers get involved. Who is expected to maintain it? Are we treating the test as code? Is it clear how anybody can contribute from day one? Megan had a great talk yesterday on contributing to open source, and it applies to any project. Is it clear? Do you have good examples? Do you have good templates? And also, how do we know our effectiveness? What proof do we think we'll need to show that this suite is valuable and worth our precious time? We're not cheap, we're expensive. Think about how much you make per hour or your salary. How many people are involved in this? Is it worth the business investing in this? And to help us inform this, we go through a risk analysis, and this is where I would go all through this. Angie had a great talk on what to include in automation. So I'll just kind of lightly touch on this. It's meant to guide prioritization of your tests in order to reduce project risks. The idea is to facilitate a conversation with your team. This might be your tester helping guide that conversation, but the full team is involved here, understanding the risks. And this worksheet was derived from Rex Black's Managing the Testing Process. He goes into a lot more detail, but you can see how we've really simplified it down. We look at the likelihood that a risk is going to occur and assign a value, one being most likely. We look at the impact of the risk if it occurs. Is it incredibly egregious? Can the user even do anything if this risk happens in the wild? And we multiply those to get our risk priority number. Once you have that, you set your threshold. So in our case, we said, all right, for this first pass, we're going to do 1 through 9, knowing that anything 9 through 16 was not going to get automated. We'd still run it for the sprint, but that was it. And we did this through a project called Guardrails, where we went through feature by feature. We paused new development to get the right feedback in place. And our result is, here's a reflective graph of what we saw. And it's what we thought we would see. So as NHTSA saw fatalities hit an all-time low, we saw what we thought we might. And for us, it was that we saw fewer critical and highs, but mostly medium. So our first pass, we really reduced the most egregious bugs coming into our system. The thing is that you're not going to get it right the first time, and you still need to iterate, and you might need to revisit that. So all of this leads me to continuous learning. We should always be doing this. Unfortunately, through that all-time low with NHTSA in 2011, we're starting to see fatalities rise at an alarming rate of 7% year over year now. But think about it. When did you get your first smartphone?
2010.
I got mine probably around 11 when my first daughter was born in 9, got one in 10, and then really started using it with my second. But yes, it's large part due to driver distraction. This is why autonomous vehicles got its start. It started as a driver assistance system, providing the building tools to now design an autonomous vehicle and to keep iterating and keep learning about driver behavior on that. And NHTSA is always monitoring what's going on in the field and tackling what's next based on what is found and reported to them. In our world, there's always something new. Things evolve faster than we can seem to keep up. For us, as we look at chaos engineering, we're constantly using the scientific method. We're hypothesizing, we're designing experiments around that, we're building, we're failing, because how else can we learn if we don't fail? So now we see a world, mostly, where our dev teams are one. They own quality. We still bring down silos and work towards that, but these principles have helped us along the way. Thank you.
Thank you. I think we have time for one question. Is that okay?
One. Otherwise, I'll be around, like just walking around, so that's fine. Yes.
Just curious.
Should be on. Yeah.
Okay. Just curious. Did you have an example to straw man? Did you see that in the book, or there's some online things?
I just created it on my own.
Okay.
It was in my head, but what I'm going to do is I'm going to post these on Git so that people can have an example of them. So I can put the actual omnigraphal file up there or a ping to make it easier to read and see what we walked through. Like I said, it's not like the final design, but it's really helped us build towards that piece by piece, and we've tweaked it as we decide, oh, well, that's not going to work for us. And so we kind of iterated, but that was the first version that I rolled out, I think last April, so we've been building slowly towards that in each suite.
Great. Thank you.
Yeah.
Thank you, Ashley.